Gases. Now, gases are really hard to see because for most occasions, gases are invisible to us. For example, the air around me here is full of nitrogen, oxygen, carbon dioxide, a host of other materials as well, but I can't see them, neither can you. It's quite transparent. Some of them you do see, things like smoke. Smoke is actually a suspension of particles in the air that hasn't been burnt up properly. But I'm going to create a bit of smoke here for you just so we can observe one of the main properties of gases. So I've got a bit of tissue paper here which I'm going to set on fire, and then I'm going to try and snuff the flame by using this beaker next to it. And if all goes well, I won't set off the fire alarm. So just leave that in there. Already you can see the smoke coming off of it. And you can see that the smoke has filled its container. Very similar in the way that liquids, when you pour them into a container, they will take up the shape of the container. Same thing is happening here. The smoke that I've created has spread out roughly evenly all over that container. A little bit below there, but if I give it enough time, it should become nice and even. We have a special name for that. When gases, or liquids for that matter, when they spread out, let's say I've got two liquids together and I mix them together, eventually they will mix together to become really, really evenly distributed. Gases will move around in another gas until it becomes evenly distributed. We call this diffusion. It's the same thing when you have like the locker area and somebody's using a bit too much deodorant or perfume and it starts permeating through the entire locker area. Please don't do that, it's really annoying. Small bit goes a long way. But that is called diffusion when it spreads out. There's a main thing about gases. What can we say about gases in their shape? Do they have a fixed shape? No, they take any shape they want, especially the shape of its container. And gas, I can smell it from here already. Because it's not a sealed container, can you see that little spout down below? Some of that smoke is coming on its way out. And unless you create an airtight or a gas type seal, gases will continue to spread out more and more and more. So they don't have a fixed shape. They will take the shape of any container that they are in. So we can put a cross in this bit of our table right here. Do they have a fixed volume? Well, not really. You can actually compress gases. I don't have the equipment right here to prove it to you, but if you're in my science class coming up this week, you will find that we do an experiment where we actually try and compress them ourselves using our hands, and you'll find that they have a certain amount of give, and that makes them not a defined volume because you could technically squash into a smaller space. That makes them compressible. So we can put a cross in this column. It's not a fixed volume, but we can tick this column here where it is compressible. And with that, we've finished our 3 states of matter. Our next video clip, I'm going to challenge you with some more tricky materials which aren't immediately clear which camp they belong into, solid, liquid, or gas, and we'll have a look as to what our answer will be.